In this video, we will learn about the pitch and its determination for a screw gauge. So, pitch is nothing but a linear distance through which the screw moves forward or backward parallel to the axis when one complete rotation is given to the screw. It can also be defined as the perpendicular distance between two consecutive threads on the screw. Now, to determine the pitch, we rotate the circular head of the scale so that the zero coincides with the reference line, that is this line. Now we note the reading on the main or pitch scale. Now we rotate the cap using the ratchet so that the screw makes a few complete rotation, let's say 4. And now we note the reading on the main scale again. Then the pitch would be the total distance moved on the main, that is the pitch scale, divided by the total number of complete rotations given to the screw. Normally, the screw gauge we use in laboratories have a pitch of 1 millimeter. Now, the least count and its determination. So the least count of a screw gauge is defined as the least distance which can be measured accurately with it. Now it can also be the distance through which the screw will move forward or backward when it is rotated such that the circular scale is turned through one division only. So this is one division on a circular scale. Okay, this would be the least count. Okay, now to determine the least count of a screw gauge, we first determine the pitch of the screw gauge and then the total number of divisions on the circular scale, that is this head scale, okay, of the screw gauge. Now, the least count will be pitch upon total number of circular scale divisions. Okay, in this particular picture, you can see there are, let's say, 100 number of divisions on the circular scale. So if the pitch of the screw gauge is 1 mm and total number of division on the circular scale is 100, then the least count is given as 1 mm divided by 100, that is 0.01 millimeters, or I can say 0.001 centimeters. Now the zero error of the screw gauge. So if the screw is rotated till the plane face Q of the screw just touches the face P of the stud without anybody in between, then the zero mark of the circular scale just coincide with the reference line, that is this line. Now we can say that the screw gauge is alright and there is no zero error in it as shown in the figure. However, in some instruments, due to manufacturing defect or due to wear and tear on the account of continuous use, the zero mark on the circular scale does not coincide with the reference line when the plane face P and Q of the stud and screw just touches each other. Such instrument is said to possess zero error. Now it can be positive zero error or negative zero error. Also, you can see in this particular figure as well that this is the reference line and the zero is coinciding with this reference line. So there is no zero error. But in these two figures, you can see there is some error because the zero of the circular scale is not coinciding with the reference line. Now, positive zero error. So if the circular scale 0, that is this 0, remains behind the reference line 0 or the main scale 0, then we can say the error is positive zero error. In this particular condition, the first, second or the third division of the circular scale coincide with the reference line when plane face P just touches the plane face Q of the screw. Okay, now the zero error of the screw gauge is positive. Now, as you can see in this particular figure, here the third division of the circular scale is coinciding with the reference line. So we can say here that the zero error would be plus 3 into least count. Or opposite to it, the zero correction would be minus 3 into least count. Okay. Now, negative zero error. So if the zero of the circular scale, that is this zero, advances beyond the reference line, so we can say it is negative zero error. In this particular situation, 99th, 98th, 97th and so on, the divisions of the circular scale coincide with the reference line. Okay. Now in this picture you can see that the 97th division is coinciding with the reference line. So I can easily say that the zero error in this particular condition is minus 100 minus 97 into least count, that is minus 3 into least count. So the zero correction would be just opposite of the zero error, that is plus 3 into least count. Okay. For correct length or thickness measurement, zero error is algebraically subtracted, whereas zero correction is algebraically added to the observed length or thickness. Please note this particular thing. Backlash error. Generally, either due to the manufacturing defect or due to the constant use of the instrument, there may be some looseness in the fitting of the screw in its nut. Now, in this particular situation, if the screw is just adjusted by rotating the screw head in one direction, and then suddenly if the direction of the screw rotation is changed, then the screw does not begin to move in reverse direction until the screw head has been rotated through an appreciable angle. Now, the error due to this causes the backlash error. The backlash error of the screw gauge is the error due to the lag between the rotatory motion given to the screw head and the linear motion along the reference line. Okay. Now, the backlash error can be avoided by rotating the screw always in one direction only. However, if it is essential to turn the direction of rotation, then do not change the direction abruptly or suddenly. Move the screw still further, stop there for a while, and then rotate it in reverse direction. Now, measurement of diameter of a given wire or thickness of a given sheet using a screw gauge. Now, to measure the diameter of a given wire or thickness of a given sheet, we put the given wire or sheet in the gap between the stud and the plane face of the screw. Now we gently move the screw in forward direction, okay, till the plane face Q of the screw just touches the wire or the sheet. That is, the wire or sheet is just fitted between this P and Q. If in this situation the circular scale 0 lies ahead of the nth division of the main scale and the small nth division of the circular scale lies above the reference line, okay, then the thickness here would be n into pitch plus small n into least count. Now to determine the corrected value of the diameter or thickness, we subtract the zero error or we add the zero correction algebraically in the observed measurement. Okay, I hope this topic is clear to you. Thank you.